It's a pleasure for me to have a chance to speak to you tonight. I've enjoyed the symposium immensely since I've been here. And I would like to pass in review as to some of the things that have happened in the last few years on the world food front, and the situation constantly changes. In a privileged nation such as this, and for that matter all of the other developed nations, I think we always take this number one necessity, food, for granted. And yet it's of the most primary importance, not only to individuals, but to families, and when there's real food shortages, nations come apart. And as we remember, only a short 4 or 5 years ago, internationally there was a great deal of confusion also when the food shortages threatened and actually existed in a great many different countries. Yet political leaders' attention to agriculture and animal husbandry that produces most of the food, and I'd like to clarify one point now that always seems to be very confused when we talk about food. I don't know where it all starts, but you hear about the great wealth of food that comes from the ocean. And when you really look at the facts and figures, 97% of all the food that's produced comes from the land, and only 3% from the ocean. So let's remember that it's this land of ours that produces the vast majority of food, and this isn't to disregard the importance of using the oceans and inland waters to produce what food we can. And hopefully, as the years go by and our technology improves, we will be able to increase the productivity of these waters. As I say, political leaders' interest wax and wane in food. When there's an abundance, not much attention. When there's shortage, then they get excited. But it isn't just the political leaders. I think they reflect the attitudes of the general public. To them, most of them, at least not groups like yours, but the vast majority of people who live in the large urban areas think and are pretty certain that most of the food comes from the supermarkets, and they aren't very well informed about how much capital investment it took to produce that food, how much hard work, and what the risks are that are involved in producing it. This seems to be unimportant all too often. I think one thing that gives us some insight into this, at least it impresses me greatly when I come back for a day or two and look at the television programs at night and invariably hear the weather report. The whole emphasis, at least with the exception maybe of some morning programs for farm peoples, is on will the weather be good for recreation, especially over the next weekend. They seldom stop to think that that weather is important from the standpoint of whether we have bountiful harvests or not. It plays a very major role, and we were talking about the stresses today in one of the sessions, the droughts, and of course it can be too much water, the floods, and it can be untimely frosts and hails, and the weather itself is involved frequently in producing epidemics of diseases and insects, and all of this again impinges on and greatly influences our ability to produce the food that's needed or to end up short. Then we take a look at some of the factors that influence food production. And food production is cyclic, and I think it's always been so, probably from the beginning of time. And this was especially so up until right after World War II. Up to that time when there were shortages of food, and this goes back to the beginning of history and probably went back to the beginning of agriculture. Land was opened, populations grew, and there was bad weather, shortages of food, famines, more land was opened. This was the way the problems were solved then. was before the days of technical agriculture. It's been repeated time and time again. But as we now look at the world, there are many countries that have very little additional new land and that can be brought under cultivation, so more and more of the emphasis is going to have to be on the technology that you people produce collectively and those in other disciplines that bear on food production. We will succeed or fail depending on how we develop those talents and how well we distribute them. I speak especially to those people who come from developing nations, and I know there's a large number of you here. And I speak as a friend, having spent 35 years of my life in food deficit, mostly food deficit nations, wrestling with these kinds of complex problems. And the problem of food production is not a simple problem. It is very complex indeed. It has many different facets. And when you are trying to expand production, one of the first considerations that you must take into account is whether there will be and whether there is at any point in time political stability. When there's no political stability, it's impossible to change food production patterns. Then there must also be political will to improve the agriculture, which is in most developing nations the vast sector of the total population, 70 to 85% in many of the developing nations. And if you aren't concerned about that sector, simply because the ones who are more articulate, and also the ones who tip over and burn cars and break windows, happen to live in the urban areas, then maybe you won't long remain in power. So that this political will to improve the lot of the masses of the people, and since most of them are in agriculture, is of prime consideration if we're going to make any progress. The arable land shrinks, as I've already mentioned. That means that we have to have more output per hectare or acre of cultivated land, and it again comes back to our technology. And we have to develop appropriate technologies. Sometimes you can transfer it after you've done enough of the homework on the farms and in the soil types and the ecosystems in which you're working. But you just can't grab technology in a different part of the world and transplant it with any hopes of success unless there's been a lot of applied research that preceded it. There has to be then, for that improved technology, the availability of inputs, meaning fertilizer, weed killers, and etc., improved seeds, or you can't make the change. There has to be distribution systems to permit those to filter out to the village level. There has to be a reasonable price for the inputs that are absolutely necessary, and that must be related in a realistic economic way to the price of the product at time of harvest. There must be credits for, in this complex world of ours, in the developing nations especially, the vast number of the farmers and ranchers are very small and humble with no money reserves, and consequently there must be credits to buy the inputs to improve or change their technology. And from all of this, if the weather is kind, and frequently it isn't, then hopefully we'll have increasing yields. But always this is counterbalanced by the growth of human numbers. And it has been so from the beginning of time. In a few minutes I'd like to show a bit about how we have come under and continue to come under ever increasing pressure from this population monster. I mentioned that food problems production is cyclic. Let's turn back the time clock a bit to the shortly after World War II. There was periods of from 1950 to 71 when in the food exporting nations such as the United States, Canada, Australia, Argentina, a number of other countries, there were vast stocks accumulated, and I have a feeling that it was very fortunate that it was so immediately after World War II, because as I read it, the recovery of the industrial nations of Europe could not have been as spectacular, and of Japan, had it not been for the vast quantities of food that were made available for the recovery after that Holocaust. Then we went into a period short but desperate, from 1972 to 75, when one thing after another went wrong. The reserves of food stocks dropped to a critical level, and food prices began to soar, and everyone got interested in food, surprisingly enough, the urban consumers especially. And of course they cursed the farmer and rancher, as is generally the case then, because they failed to comprehend the complexities of agriculture. And now we have recovered in the last 6 or 7, or the last 3 years, and we again see food stocks building, depressed prices in many cases, and this again sort of confuses the issue as to what lies ahead. Now, what are the outlooks for the future? But first let me go back just a minute. You remember in 73 and 4, when the food crisis was at its worst and there was famine in many countries, the Sahel especially, and although probably only I say, a few 100,000 people actually perished from hunger and famine, one more bad year might have made it many millions, because the stocks were at this very critically low level at that time. And it was then that the United Nations called, at FAO headquarters, the World Food Conference to see what could be done about this. And of course there was great rhetoric and great promises by political leaders from all stripes of nations, and such irresponsible statements were made that no child would go to bed hungry by 1985, and hunger would be licked completely by the year 2000. Were it so simple. But this is the way things go. But there were some concrete things that seemed to happen at that time. For the first time, there was a lot of concern about trying to establish an international grain reserve to which modest contributions by all would be made. That would be a standby reserve. Not much has come from that up to now. There was, at that time, because of the crisis, emphasis placed on increasing the food aid to the food deficit nations. A considerable amount of progress and help was made available during that critical period. And then again, the International Fund for Agricultural Development was established under the World Food Council, and about $1 billion has been accumulated up to the present time, and the first grants have been approved to use these in various ways to try to stimulate production, increase production in these food deficit nations. Now, what are the present trends and the outlooks, let us say, for the next 10 years, 11 years? Detailed study was made by the International Food Policy Research Institute, of which I happen to be a board trustee member, and I guess I'm the only dirty-handed agricultural scientist on the staff. All the rest of them are agricultural economists. So I try to keep them honest. Is that all right? They published a bulletin in 1975, which pretends to project ahead what the world is likely to look like, food-wise, up to the year 1990. And it isn't a very pleasant picture. And I should say that they used as a baseline the production from the year and trends from the year 1960 through 75. And the way this worked out is that by the year 1990, the deficits at the beginning of that period, 75, which were 13 million metric tons of grain in the 12 most seriously most seriously deficit or likely to become deficit nations, showed that they were importing then 13 million tons of grain. Using those projections of trends of production in the past and consumption, those deficits would grow to 70 to 80 million tons by 1990. Then if you corrected just simply to keep per capita food consumption at what it was in 1975, taking into consideration population growth, you would have to add another 35 million tons. So this totally would mean that you would have to, these countries would be importing somewhere between 105 and 115 million tons of grain by the year 1990. Sounds good to American farmers, I'm sure, and Canadian farmers, but you have to stop to realize that many of these countries have little foreign exchange. They're very poor, and the amounts of food that they can import is rather limited. Let's just take 2 or 3 of these countries to give you some idea of what was anticipated in this study. India, which was importing in 1975 1.4 million metric tons of grain, if these projections are correct, will be importing 17.5 to 22 million tons by 1990. Nigeria, which was importing 0.4 million metric tons, will jump to 17 to 20 million metric tons. And Bangladesh, which was a deficit of 1 million metric tons, would climb to 6.5 to 8. I'm not sure that this is at all realistic, and I'll tell you why. I tried to convince my colleagues, but I wasn't very successful. If you take the 1960 to 1975 span, and I think we can illustrate this by using the situations in India and Pakistan. Nothing was happening in agricultural change from 1960 till about 67 or 68, when production started to change. First in wheat and slightly later in rice and maize. Now, what's wrong with the statistics then? And I think that here's one of our real problems in coping with coming to grips with food production problems, is that the statistics are very poor. And then secondly, in this case, too much of, say, from 60 to 67 were before anything happened to change production. And then there were 2 years when there were shortages of fertilizer in 74 and 5, and shortage of diesel fuel following the embargo on petroleum, when production actually dropped in the case of India substantially because of those 2 inputs not being available at prices that farmers could afford to pay, with the control of the grain at 1/3 of the world price at that time. So why do I think that these figures might be misleading? Let's take a look at India. In 1965, its wheat production was 10.5 million tons. This was before we got this thing moving a bit. It had climbed by 68 to 16 million, and at the International Genetic Symposium in 68 in Canberra, Australia, I predicted that it would climb to 24 million tons by 78. Actually, it reached last year 31.5 million tons. The change in wheat production in Pakistan up until a year ago was of a similar rhythm. And this too we anticipated. Now, I say that India has the capabilities, if it has the political will and the need, to produce 40 million metric tons of wheat instead of the 31 that it harvested this last season by 1988. I doubt that it will need this much. It should diversify and produce more of other crops. but it's indicative of the kinds of changes that are taking place. It is not just wheat. In the last 3 or 4 years, there's been rapid increase in rice production. Maize production has climbed. There's a need for increasing oil crops, and always we hear the noise about you giving too much emphasis to one crop. What actually happens is that the technologies haven't been developed at the same rhythm for many of the other crops. I'm against holding up the fast runner to let the slow one catch up. I say prod and kick the slow runner and see if you can get him moving. And this applies to research, to the extension people, and to the farmers who produce those products that are in short supply. There's been a great deal of progress in many other countries, and so it's continuing. In Turkey, in the People's Republic of China, where I've had the pleasure of visiting twice in the last 4 years, in Taiwan, South Korea, Tunisia, in Brazil, Argentina, Bangladesh, and from what I read, the Soviet Union is spending more monies than ever before in expanding its fertilizer production and developing more of its irrigation resources. I haven't been there for quite a number of years, but all of these things together and changes in many other countries that I haven't mentioned, I think indicate that if there is world stability, political stability, if there's no war, if there's a will to produce this food, we need not have this problem that was painted so dismally in this report that I've just referred to. Actually, at the present time, India has an entirely different problem. Their warehouses are overflowing, but there are still many empty stomachs among the unemployed and underemployed people of that nation. This is a new ball game, as it were, to them. They believed it couldn't happen to them, and now they haven't prepared themselves for it. I see a challenge there like I saw during the depths of our depression here in the United States, when under President Roosevelt, the Public Works and Projects Administration, WPA, Civilian Conservation Corps, and other types of emergency programs were established to give employment so that people could buy food and the other basic necessities for life. And I happened to be at that time a young professional forester who supervised many of those work crews in both types of projects. And I've had the privilege and pleasure to go back and look at some of those forests that we planted. They're mighty nice, they're productive. And some of the soil conservation projects that I was involved with. These are opportunities now for countries such as India. I hope they know how to take advantage of this. And I am pleased to see the ball, as it were, over in the court of the planners and the economists, because for all too many years, those of us who have been working on the food production line, and I've always said that you can't distribute something you haven't produced, have had our ears burning by such accusations and cliches that we are simply making the rich richer and the poor poorer. And why haven't we produced a technology that is good for the small farmer, but implied that it wouldn't be suitable for the big farmer? In other words, I guess that really means that you would produce a variety of wheat that would be high yielding on the small farm and low yielding on the big farm, so that everything would work out in this utopian world that is perceived by some of these people. And they wouldn't have the nasty job of distributing the benefits and the equities that come from an expanded production. And then, of course, we've had those who said that you must certainly be able to producing a high-yielding variety that doesn't need fertilizer. And I said, yes, I think we can, about a year after you produce me a man and woman that doesn't need any food to pontificate from nice ivory intellectual towers. That's the challenge, but I haven't got any echo back from that at this time. Sometimes it reminds me of a story that one of my, and I say this to the students, I see there are quite a few graduate students here who are interested in development of rural economies. And one of my Danish farmer friends, in reflecting on how hard it is to provoke change in developing nations, in the agriculture of developing nations, equates it to an overloaded freight train that has a locomotive that's too small to really get it moving. And it goes, help me, help me, help me, going better, going better, going better, don't need you, don't need you, don't need you, go to hell, go to hell, go to hell. And young men and ladies, this is the way it is when you try to provoke change. Everybody is fearful that the change might be worse than it is at the present time. And the bureaucracies that you have to deal with, and you have to keep smiling, even though you want to cry, very often, is very hard to move it, even when you have the technology. And to those young people, I say that if you decide to go into a career of trying to help expand food production and provoke constructive change in developing nations, then I advocate that you develop the patience of Job, the determination and stubbornness of a Missouri mule, and a hide as thick as that of a rhinoceros when they're shooting darts at you. And preferably, if you could develop deafness at the right time, but then turn it back on again when you want to hear things that are of importance, it would be very helpful. I don't mean to imply that I'm cynical, not at all. You have to laugh at yourself, you have to keep your good humor, or you are not effective. But sometimes, I assure you, it's very frustrating. Can we stay ahead of this population monster? And I think we can, if we have the political will, through the 90s. If, and here's the big and I'm going to spend the rest of my time talking about this big if we can keep disease epidemics under control in the basic crops, and I refer especially to the self-pollinated crops. I'm not going to use any technical terms here because many of our audience is not technical. This is where we're trapped worse because of the nature of the pollination system. We can't go back and undo the evolution that's gone on for the last 25 years since the grass has spread across during the Miocene age, and Neolithic woman picked out maybe the wrong crops to start to domesticate in the first place, except for corn and sorghum that have an outcrossing system. We can't do much about that. We got to live with it. And we have to try to improvise in order to defend ourselves as far as possible, as best we can. I would like to point out two cases that illustrate very well why I'm concerned about controlling diseases. In 1975 in Mexico, for the first time in about 33 years, there was a leaf rust epidemic that got out of hand, and it was finally stopped and controlled by chemicals. And it's the first time that I've ever seen in my 33 years at that time, 8 different factors come together and mesh together in a way that the scientists had no control over things. 8 of them. First, there was land invasions of private properties and lack of confidence of the farmers as to whether they would have land for the next season. There was political instability. It was at the end of a administrative session before and during elections, which added more confusion to the situation. Then there was drought. Ordinarily, when the wheat crop is harvested, immediately the land is prepared and soybeans are planted. or maize in the summer. But since there was shortage of water and the uncertainty of who was going to own the land next fall, the farmers didn't fallow. The stubble was left. I had searched for 30 years to find overwintering leaf rust or oversummering leaf rust in the area, and I had never found any. But the situation was right. There were light rains in the end of June and again in July, and there was quite a bit of volunteer wheat, and it got rust on it. Nobody bothered to fallow, again because of the uncertainties of land tenancy. And the stage was set. Didn't rain in the summer, and finally in the end of September there was a hurricane that dropped a lot of rain on the coastal area but didn't have enough wind to push it up into the reservoir. Then immediately people looked at some farmers, and then mostly small farmers, looked at the shortage of irrigation water and said, if we don't plant now, we won't be able to plant at all. So they planted 2 months out of season, picked up the rust from the oversummering, and then make it even worse. Most of the other farmers still couldn't decide whether they were going to have land of their own or not, and so they delayed planting till the ends, which we normally make in November and the first week in December, to the end of December and into January. And so they picked up all of the inoculum. Now, these 70,000 hectares where there was massive amounts of inoculum were sprayed with Bileton and Indar, and the epidemic was stopped. Fields that were not sprayed yielded 800 to 900 kilos per hectare of chicken feed. It wouldn't make good chicken feed, and the other was 5 to 5.5 tons of good grain. It was the difference between a disaster and salvaging a good crop. Last year, there was a repeat, but the situation was much simpler in Pakistan. The races of leaf rust again. And I should say that in the case of Sonora, there have been leaf rust around, but it generally comes late in the year. And even when races or varieties become susceptible, it causes little loss. In Pakistan, the races had changed 5 years ago in '73. 3 new varieties with resistance to those new races were released from the station. The seed organization, a government monopoly, again didn't function. And the result was that last year they had ideal conditions for epidemics of leaf rust, and they're importing 2 million tons of grain. The year before, they harvested an all-time record. Now, when these things happen, scientists also like to cover their back trails, and I don't blame them. I guess I would too if I were in that shape. And the explanations were given that it was change in or high temperatures when the grain filling period that caused this loss. But the curious thing is that right across the border in India, no geographic or no geographic differences, the same climate, the same soil, the varieties had been changed, they harvest a record crop, and on the other side, this happens. This is the biggest danger that we have in keeping food production on target. I became interested in multi-line development, which is really, for those of you who are not working in agriculture, to develop a series of lines with different kinds of disease resistance. They look alike from the standpoint of the farmer. The grain characteristics are similar from the standpoint of the miller and the baker. And what you do is to multiply a series of these lines with different kinds of resistance, multiply them separately and mix them and feed them into the seed system and into the farms. I got interested in this in the late 1940s when I first visited Argentina, and it was at a time when there had been a very severe outbreak of stem rust that destroyed the variety Klein Cometa, which was grown on 70% of the area. It was a disastrous epidemic. And the year later, when I was in Argentina, and the Argentines correctly pride themselves on the good bread that they make. They were eating bread that was half wheat and half sorghum, and it wasn't so good. That made a deep impression on me. I came back to Mexico, and that same year, or in 50, a couple of years later, the outbreak of 15B stem rust race across the North American continent. It spread rapidly. First 2 years, there weren't too much damage. All the varieties in North America of wheat in the Great Plains from here into Canada were susceptible. And the right combinations of weather and early inoculum came together in 53 and 54 and created a devastating epidemic. And this is what interested me in trying to do something about this in this so-called multi-line approach. But we had arrived at a point in 1958 when we had 3 years of data and we were ready to, could have multiplied a tall multi-line variety. Farmer would never have known the difference, neither would the miller or the baker. They had different resistance, and we had enough experimental data to feel confident that it would work on farms and be additional protection to the farmer when races changed. But about that time, we had these semi-dwarfs far enough along so that we could see that the yield base had essentially doubled compared to the tall strains that we had in the multi-line. Since we had no stem rust epidemic or on the horizon, we didn't distribute this variety. Then we had to go back and we had to put the multi-line on the back burner, if you permit me to use that figurative expression, and go to work to fix up the high-yielding first semi-dwarf varieties which were distributed and which spread like wildfire. The farmers were enthusiastic, and it was those same early varieties that produced their impact in, and some subsequent ones in many countries of the world. But seed had to be further improved, the quality of milling and baking, broadening of the disease resistance, and this took time. And also, by 1963, we were deeply involved in the problems of increasing production in India and Pakistan, and so nothing happened on multi-lines again. Now I am proud to say that my good Iowa colleagues here, Doctors Fry, Browning, Simon, have carried through, have put into operation, have built a new approach into plant breeding with their multi-line varieties that have been highly successful over the last 7 or 8 years in oat. I am equally pleased that one of our colleagues who is present here tonight, Dr. Kim Singh Gill from Ludhiana, Punjab, India, at this released the first multi-line wheat variety in India, a high-yielding one, and within the next crop cycle, 2 others of those multi-lines will be increased in India. Now, in order to make these function right, I think that we have to have a new look at how we're rating disease resistance. And I don't want my good friends who are the masters at handling major resistance genes, whether they be stem rust, like my good friend Doug Knott, or the leaf rust LR genes in other parts of the U.S. I'm not talking against those. I'm simply saying that we need to find some way to combine those effectively in identifying broad types of resistance built on these polygenic minor genes. These are, to me, based on my experience, much more stable, but they're very difficult to identify. You don't know when you have them. And especially if you have a major gene superimposed, it shades out all of the effects of these small quantitatively accumulated genes. So I think what we have to do Artie, is we have to re-educate our plant pathologists to take notes in a different way, to interpret the rust readings differently, and I think this goes for the plant breeders also, and this is no small job also. You people have blazed a new path. I admire your courage. It takes courage to change something that has been productive, successful, as was conventional pure light breeding, although it has this Achilles heel, which we've mentioned. So, as I look down the road, if we can use this, improve on how to identify these lines that carry this polygenic minor gene resistance, and I'm convinced there are massive numbers of these. And you see evidence of this in Dr. Niederhauser's potato breeding program, where he's made many crosses, not only with Demissum, but other species. After he's tested in the cradle of the Phytophthora late blight in Toluca Valley, he's been able to identify some cultivars that have been grown now for 18 to 20 years with only very minor erosion away of resistance. They're still perfectly functional. And we thought this wasn't feasible a few years ago. When I look at how these minor genes are used in other types of plant breeding systems, not necessarily for disease resistance. My colleagues in the maize program in Simmet, for example, Dr. Elmer Johnson has taken these enormously tall tropical corns and reduced them by more than a meter simply by recurrent selection using these very small genes, which hasn't thrown out of synchronization many of the other yield genes. This could be done very rapidly with some of these dominant strong genes, but when you do that, well, you upset the whole equilibrium. Whereas with the other approach that I've just mentioned, this hasn't been so. In the incorporation of the high lysine improved nutritive value characteristic into mazes, of course you change the whole texture of the kernel, and this just wouldn't go. You change the yield patterns also. But through a magnificent job of close collaboration, as I see it, between Dr. Vassal in the genetic side and his assistants and Dr. Evangelina Villegas in the biochemistry side, they're bringing these back together with the modifiers, and I defy some of you, or I defy you now to be able to distinguish between the normal and the one that's got the opaque, high-value nutritive characteristic incorporated and back into a hard kernel. Whether they're entirely stable yet under a range of environments remains to be seen. But these genes are around in big numbers. It's a question of getting out and finding them and identifying them and bringing them back together. So, and yet I know that there are many people who say that this will probably be a disaster, this kind of a breeding approach. You'll create super races of the rusts, and they'll eat us all out of house and home. And yet this hasn't happened in open pollinated corn varieties that are susceptible, or that have their two species of rust in the home of the corn or maize plant in Mexico. They live in, if not happy equilibrium, they're reasonably happy. And unless man shakes the tree and changes it too much, they'll stay in harmony and very little impact. If you want to look farther back in geologic time, you will see that in the rust fungi that attack pine trees, this same equilibrium exists, except when man again pushes it out of balance. They haven't developed super races of Carnartium ribicola. So I think there's no fears there. The one great advantage in developing nations, and I'm talking about the use of these in developing nations, is that you can bypass, if need be, the seed organizations that don't function because of bureaucracy, because of complex regulations. The same is true for many of the other complications that have to do with government snafus of one kind and another. The research scientists can simply multiply and make a composite of the 10, 15 lines, and if he has 25 tons of seed, if he measures these out into 5-kilo lots, he'll have 5,000 of those. And if he feeds these into small farmers, sprinkled through the zone where this variety has been grown successfully, and tells these farmers, and don't get the idea that just because they are small and very often illiterate, they are ignorant. This is one of the misconceptions that's very widespread in the world. These are shrewd people, and if they hadn't been shrewd, most of them they would have starved to death long ago. And I dare say that many of us couldn't survive on the piece of land that they're surviving on. Yet they're receptive if they are given the information that they need to make the decision. By such an approach, you can, when the warning comes, you can move out these multi-lines, you can get them in place very easily. Hopefully, we will get better seed organizations. And I know that many of you in the private seed sector will say, why don't we have a role to play? It's curious, but in most of the developing nations, there's a fear of the private sector companies. I have a feeling that part of this comes from a reflection on their colonial days. But it's not necessarily so in all countries. And again, you will find this same fear or lack of interest, call it what you will, in many other countries in Latin America, where, again, the seed monopoly in a government service is conceived as the best way to handle improved seed. I think it's probably best from the standpoint of the politicians, but I'm not sure that it's best from the standpoint of the good of the farmer and the good of the total economy. So can the world feed itself? Not up to 1990, which I said yes, by all means, but let's take a look at the next doubling. Agriculture presumably started about something on the order of 12,000 years ago, and although it's speculation, there were probably 15 million people living at that time when Neolithic woman domesticated most of the same plants that we derive our principal foods from today, with the exception of maize here in the Americas, which came later. I'm speaking now of cereals only. And I suppose she saw that this was absolutely necessary when the old man and the older sons were bringing home less and less meat to the cave because the herds were dwindling and food was getting scarce. And she decided that these wild grains that she'd been collecting for all of these probably centuries, she and her ancestors, she better plant them. And so agriculture was born. From the time of the discovery of agriculture, assuming 15 million living people at that time, that population doubled 4 times to the time of Christ, bringing it up to about 250 million. From the time of Christ up until 1975, it doubled 4 times more, and each time, of course, the period of doubling was shorter, as is illustrated by the first doubling from the time of Christ onward took 1,650 years to bring it up to 500 million. The second doubling from 1650 only took 200 years to bring it up to 1850, which is the time of the discovery of medicine, modern medicine, knowledge of contagious diseases, improvements in health. And the next doubling, third doubling took it up to about 1935, which was the time of the discovery of antibiotics, or shortly before sulfa drugs, and then antibiotics, and again the death rate plummeted. The last doubling took only 45 years and brought us up to 4 billion approximately by 1975, with population growth going on as it is now. Or let me reflect. So from the discovery of agriculture until 75, population, that beginning population doubled 8 times, or increased 256-fold. The food production in 1976 was 3.3 billion metric tons of all food, and as I have mentioned before. 97% of it came from the land. In order to maintain the same per capita food consumption for the next doubling, which probably, if population growth continues as it does now, will occur by about 2015. That production will have to grow to 6.6 billion metric tons. In other words, we have to increase it again as much from 1975 on until the year 2015, in that 40-year period, as we were able to do from the time of the beginning of agriculture to that 3.3 billion metric tons in 1975, a very sizable task. But we can only bring this on stream so fast. If we bring it on too fast and you get the accumulation of stocks that you can't distribute, you'll destroy the farmer. The depressed prices in agriculture here reflect how difficult it is to maintain this balance. And yet there are many hungry people in the world, but the lack of purchasing power, the lack of foreign exchange, all of these are complexities that we haven't found out how to deal with. Now, in closing, I would like to say that this challenge can be met, but only if we have the political will, the right investments in agriculture. If we don't go to sleep on the energy front, and I get real concerned about lots of this idle talk coming out of elitist mouths about agriculture shouldn't use scarce energy for fertilizer. And those people who are often giving forth with this point of view have 2 or 3 automobiles in their garage and air conditioning in summer and have the thermostat turned up full blast in winter. So I'm a bit skeptic about some of these things that are being pitched around as being the right way to do things. I hope that my friends in the environmentalist issue will keep halfway in the middle of the road, and unless they do, we'll have more and more trouble. And this is not to say that I'm against, let me put it this way, I'm against the reckless use of agricultural chemicals, just as I'm against the reckless use of medicine. If you take medicine right, you're ill and has been diagnosed properly, you take that medicine right, it'll probably cure you. If you take it improperly, it'll probably kill you. And so it is with many things, including an automobile. We seem to do a good job of killing 50,000 people a year with automobiles in the USA, but imagine the scandal and the outcries and the noise that would come out from the general populace if 50,000 people were killed by some kind of a chemical. It's a curious world. And then we go out in the endangered species. If we're really concerned about the endangered species, let's do something about the growth of human numbers, or many of the species that are endangered will be pushed out of existence because of destruction of their habitat. It should be self-evident, but no one wants to talk about the total carrying capacity of the planet Earth, or for that matter, closer to home, of the ecosystems around about us. How many people do you want to have there? How many horses? How many dogs? How many this? How many that? How many elephants? And all of this has to be brought into balance. And it has to be a decision made by the general public. But there are so many people that are riding off in different directions, and then this has become the mother lode for lawyers in the last 10 or 15 years. They never had it so good, never found so much gold as in the Delaney Clause and various of these kinds of bits of legislation. So those things too will all have to come into some kind of balance. And we've got carcinogens everywhere. I suspect we've had many of them for a long period of time. Some of them certainly are accentuated by pollution from industry and elsewhere. And then we have this Delaney Clause, which just simply mistreats this rat the four-legged rat, miserably. First, you force him to inbreed, sister and brother matings, and then you select out the strains that are completely susceptible, as far as you can make them, to cancer carcinogens, and then you load their rations as heavily as you can, but you don't want to kill them with that. You just want to make them real miserable and keep them alive as long as you can, and see if you can't make them produce a cancer or a tumor, and then you ban it. So that's the way it goes. That poor rat. I'm talking about the four-legged one. And then also we get into this human rights deal. Human rights for whom? The elitist? To me, those are cliches that have very little meaning until the masses of the world's population, especially in the developing nations, have food in their stomach, a shirt on their back, a roof over their head, a job to gain their livelihood, their children in school, and when they're ill, they can go to a doctor. Until you have those basics, you aren't too much concerned about dissenting, about how you express yourself in public. Those things come later, and I'm not trying to minimize the importance for those who are privileged enough to enjoy those at the present time. So I see that the situation has gotten about 10,000 people worse since I started to talk. So you better all get back to work, or we aren't even going to make it till 1990.
Thank you.